Using a constant voltage welding machine enables the arc voltage to remain at its operational level, even during those times when the electrode is in contact with the metal. Regardless of the type of current or the type of output that a welding machine generates, all welding machines get their power from one of two possible sources. One source of power is an electric utility. When a welding machine uses commercially available electric power, it has to change the high voltage low amperage alternating current from the utility's power lines to a low voltage high amperage AC or DC welding current. While electric motors were once used for this conversion, modern welding machines use transformers to produce AC welding current. To also produce a DC welding current, the transformer's output is connected to a rectifier. A rectifier is a device that changes alternating current to direct current. In situations where electric power is not readily available, a welding machine that generates its own power can be used. These machines use an engine that runs on either diesel fuel, gasoline, or liquefied petroleum. The engine drives either a generator or an alternator. DC, AC, or both DC and AC welding current is then available to the welder. The size and type of the engine used depends on the size of the welding machine. Another characteristic that's common to all welding machines is duty cycle. A welding machine's duty cycle is the percentage of 10 minutes that the machine can continuously produce its rated amperage without overheating. A welding machine can be seriously damaged if its current rating is exceeded. For example, a machine with a rated output of 300 amps DC at 50% duty cycle can deliver 300 amps of welding current for 5 minutes out of every 10 minutes without overheating. The greater a welding machine's duty cycle, the more heavy-duty it is considered to be. Duty cycle information is often plotted as a graph that welders can use during equipment setup. Because of advances in technology, welding machines today can do more than just supply current. For example, some welding machines can provide DC welding current with improved efficiency, while others allow welders to modify alternating current to suit the needs of a particular job. Well, in this part, we took a good look at the machines that are commonly used to perform arc welding. We did this by covering some basic characteristics that are used to identify and describe these machines. Now's a good time for you to try a question about welding machines. Well, in this part, we took a good look at the machines that are commonly used to perform arc welding. We did this by covering some basic characteristics that are used to identify and describe these machines. Welding machines are able to provide welding currents of up to several hundred amps. To make this current useful, there are many accessories that can be used with the welding machine. Some of these are required for the proper operation of the welding machine, while others are optional. For example, welding current is carried by a heavily insulated electrode cable. The cable is specially designed to have a minimum resistance to the flow of current. This is important because any change in the rate of current flow will affect the welding process and therefore the quality of the weld. The electrode cable carries the current to the electrode holder. This particular electrode holder is used for shielded metal arc welding. The electrode holder is controlled by hand to form the weld. The grip or handle of the electrode holder is insulated to prevent the welder from getting shocked. The electrode fits securely into the end of the electrode holder. It is the tip of the electrode that conducts the electricity to the metal being welded. The work cable is made of the same low-resistance material as the electrode cable.